I've called this backbone of industrial Internet of Things and then Industry 4.0. I think the first part of my presentation is really want to give you a little bit of an idea of what we as network people think about this topic. It was really good to see from Ross this morning what he gave from the IBM perspective in a much bigger scale. So we, with the networking, we are just one part of the Internet of Things. It's the transport of data, actually. So some basics. Vision of Industry 4.0 covers three aspects: the horizontal integration across value networks, end-to-end engineering, and vertical integration and network production systems. So what you see there for what the European version of the industrial Internet of Things is really a lot more focus on the manufacturing background. Yeah, while the Internet of Things, and I think you see that in captures this a lot bigger. It's a lot bigger. So smart factory manufacturing is only one part of the Internet of Things. Yeah, but this is the part for us today, or in particular for us from Profibus PROFINET, is what I'm going to talk about. So more about the manufacturing processes, more about the devices, and what we have, and delineate of what we're talking about. The other, if you look at the Internet of Things again, that is these aspects that are part of a much bigger picture that we talk about. So I'm not going to talk about smartphones today. That is something that may affect us, may make things a little bit easier. But for us in the network area, it's really more how can we manage to bring the data across. So what is the role of connectivity in network technology? This is a reference architecture for connecting the Internet of Things with the Internet of Services. And you see connectivity is only one part of that. But the relevance of that is that it's a link in the chain. So without that connectivity, no Internet of Things. And that is what we have to overcome. That's why we believe that our technologies are really relevant to this. The other part that we really need to stress is Internet of Things and industrial Internet of Things. Two really different kettle of fish. One is the legacy, that you can see here. So you have got lots of existing plants that already work on network systems. You won't go to a manufacturing plant and throw out all their existing bus systems. So you need to find ways to set up on that and use that. The other thing that really is interesting, the Internet of Things is about things. The industrial Internet of Things is more about data. And that's what we heard this morning. And if you see this from the colleagues from GE, consumer Internet of Things, 7 billion plus people today. But if we look at the industrial Internet of Things, we're looking at 50 billion connected devices in 2020. So that sort of shows to me that there is a lot more data management necessary, and we're talking here about lots of data, and we're talking about tons of data. And I think Ross gave a right description this morning when he said the amount of data that IBM is expected to need to be made available for these technologies. So talking about the legacy, this is the reality that we see now. This is a study from 2015, released in January, and it shows you that the majority of networks that we find in manufacturing and in process control is still field bus. But field bus needs to be part of the industrial Internet of Things too. You cannot do without. You cannot exclude them. So there's already networking there. It's just a different platform. It's not Ethernet. Ethernet is coming strongly, absolutely. You see that here. 1/3 of all the installations are Ethernet. And of course, there's a lot of players in there. The PROFINET that we represent, EtherCAT, where Steve will talk to you about, Ethernet RT, Daniel will talk about. So, but the reality is, we need to be able to manage all of these if you want to really realize these through and through networking in our system. The biggest challenges, again, this is from a recommendation from implementing Industry 4.0 out of Germany. They reckon standardization is the biggest one. So that means, hey, I know that I've got all these different systems. How can I actually put them all together and make them talk to each other? One of the key messages that I wanted to bring today at the core of Industry 4.0 and IIoT is the need for interoperability of devices, software, and entire systems. So the question then is, what will the future network look like? fact for me is nobody can really tell you at this point in time. There's so many unknowns still, and we know how quickly technology develops. Going back to the examples that we have heard this morning, often and often with a mobile phone. Things that we think is inevitable: remote access, guaranteed quality of service. So security is another aspect that we're going to talk about extensively in this conference, I believe. Use of commercial off-the-shelf hardware, and all these other things that you can read here written down. Multiple protocols. So one of the things that we're looking at with PROFINET and many others too, and I believe that very similar to what Ethernet does too, is using basically translators that turn your data into information. We are really good at transporting data as network people. We are not so good in turning these data into information. It is what protocols like or tools like OPC are about. OPC UA is a standard that is now not only linked to the old Microsoft, so that's a unified architecture, and that are other enabling technologies that they need to be considered in this. So PROFINET is responsible for the provision of real data, and OPC offers a perfect extension for internet technologies. So we're looking for technologies that actually are able to match data from different sources here. PROFINET. So I want to talk a few minutes about what PROFINET is and where it comes from, because we want to sort of contrast the different networks today and see what makes one network different to the other one. What is it? So firstly, we say it's industrial. It's an open industrial Ethernet standard, defined in IEC 61158, and absolutely standard Ethernet. So what that means is from your office environment down to the Profibus layer, there is communication. They all work on the same systems. You can, if you want to use a standard switch out of your office in an industrial application. It doesn't make sense because it's not industrial hardened, but you could. From a data transmission perspective, that doesn't make that difference. It uses standard TCP/IP communication for non-time critical tasks. It's highly deterministic, and I'll show you in a few slides what I mean with that one. And it provides seamless integration with the legacy buses that we still find in many applications, and will continue to find. Kaveh will talk about Fieldbus Foundation. That's a Fieldbus used in intrinsically safe applications. There is currently no real Ethernet system that can provide that. So you have to, in many process automation applications, you need to have either Foundation Fieldbus or Profibus PA if you want to use a bus system. PROFINET, just some simple things. So what you see on the left, that is standard real Ethernet. You find everywhere in your office environment. What you see on the right is a real-time feature for PROFINET, where we basically bypass layers 3 to 6 to have a lot quicker responses and provide a channel that is deterministic to your response times. For us, yeah, of course, we say we are the right tool for Industry 4.0. It's about all these features here which we think that we are advanced, and I'm sure that Danny will have a slightly different opinion to that one, so will Kaveh, so will Steve after that, and that's what it's about. The thing is, if you want to be, as we said this morning, innovative, we all have to push to find the best solutions. Performance, flexibility. So why do we think PROFINET is ideally suited? So to answer this, I want to go to the different fields of application that we very commonly identify in our field. So that is process automation, that is factory automation, that is drives. One of the significant different demands in there is speed of response. If we talk about process automation, well, the temperature in a big tank doesn't change over in a microsecond, so you've got time to do that. So for that application, PROFINET has got an exclusive TCP/IP layer that enables simple exchange of any data with response times up to 100 milliseconds. For real-time features up to 10 milliseconds, which most of the factory automation parts would be happy with, real-time features actually handles cyclic signal exchange of I/O data with response times up to 10 milliseconds. And then Profibus has got for synchronization of drives what they call isochronous real-time, and that can bring down the response times lower than 1 millisecond with a jitter, so a guaranteed response at the same time, at the same cycle time of 1 microsecond. So very, very important to accurately position drives and positioners and those things. So this is where we feel with PROFINET are the three main areas of factory automation and process automation that we can cover with the technology. A few words to process automation. Again, there's different demands there. One is the field bus integration. Again, I've said before that we have got lots of legacy systems that have to still be included. We have got the hard protocols still with devices in there, Profibus PA, Foundation Field Bus, Profibus DP, and many others. In process automation, also what we see is the need for configuration in run, typical to meet the demands of things that can be done with the DCS system too. Scalable redundancy, and we have got 3 redundancy systems here, so we have controller redundancy, media redundancy, and device redundancy opportunities here. And time stamping, for example, is another feature that is in the latest specification of PROFINET for process automation. All right, high-speed applications. What I showed you before, isochronous real-time for motion and applications with the Profi drive profile. So we can achieve down to 31.25 microseconds, while the TCP/IP layer is still there for engineering and diagnostics. So once you have your process data, the other one is engineering data, and you can both run all over the same lines, while in parallel you run a very, very fast response time with the PROFINET. Security, and I guess this is one of the biggest topics that we in the Ethernet world will face. And we had it on the last conference last year, and we had some really, really good talks about that too with the group. Security for systems without their own security devices, real-time operation, transparent and cost-efficient integration, robustness. I remember the talk last year from the gentleman from Ensto. I think he's here again. And that was probably the high end of security that you can cover. For PROFINET, we have got these simple guidelines of what we do, and they are sort of in line with what is the expectation in the IT world and what is the expectation in the process automation world. Those are slightly different in that regard. Fundamentally, I want to only use a few minutes in this. There's different strategies. The Great Wall of China strategy basically means you build one barrier and hope that nobody comes through. So, and you know from the old Telfer ad, if the rabbit ones come through, all the rabbits come through. So that is sort of the problem with a single security measure, which is not good enough to prevent intrusion. So what we really argue is defense in depth, where you see the old castle here. It's got several walls here, and it's very, very hard to penetrate from one to the next. In real life, defense in depth is creating the multiple layers of protection. And starting, firstly, we see the potential threat here to the DCS. Then we look at the physical layer, so physical access to facilities and equipment. We look at policies and procedures. We look at security sales and demilitarized zones, secure architecture based on network segmentation, firewalls and VPN, system hardening, user account management, patch management, and malware detection and whitelisting, and all those different features that you can use in that one. So really what it says is there is no 110% safe system out there. And a lot of what we recommend for our Ethernet systems is also standard practice in IT environments. So foolproof systems are not there, but defense in depth, because it should not rely on just one measure. The reasons for using PROFINET: firstly, these are general reasons that apply to all the other guys too. The seamless enterprise-wide integration, global accessibility, unlimited node count. That is what Ethernet makes so relevant for us now, because we are looking at, as I said before, 50 billion devices to be networked. So the networks will get much, much larger than they are now with all the Profibus systems. TCP/IP and Internet, web compatibility with real-time determinism. Ethernet cabling makes it a lot easier. If you look at RS485 based bus systems like Profibus, there's always the first layer, the mechanical layer, which causes you the problems. And that is much easier to manage with the Ethernet cabling. Wireless and functional safety, protects investment. From a PROFINET perspective, we of course think that since we use in very, very similar engineering environments, it's a lot beneficial if people use PROFINET as well, and Profibus. Modular flexibility, and so forth. Network of the future, coming back to that topic. We see three different real main streams there. One is the connectivity. That means open standards, really the ability of different protocols with different technologies and different devices to talk to each other. We also see uptime as the one element that is really, really decisive in the application, because you really want to make sure that you have total availability at every time. And in this context, I think I included the different security objectives that you have in IT and in process automation. So in IT, in business, confidentiality, integrity, availability, while in process control, it's the other way around. Availability beats integrity, beats confidentiality. Yeah. And innovation, I think one of the messages I wanted to bring is that there will always be different protocols. And there's a reason why there are different protocols too. And that means there's a reason why there's the things that Daniel is going to talk about and Steve is going to talk about. And we would be blind to say we are the only one that can do it. We had that in the 90s in the Profibus war. Everybody said, I only can use my system because everybody else's is crap. That is no longer the case. So I don't think that we have a battle this afternoon, as Jeff said this morning. I think we want to share ideas, and we want to listen to all you guys of where we can what we can do to bring us forward in that one. Ethernet will be the future, though, for all of us, and that is all I have to say in this short presentation. Thank you.